back. This is Algebra 2, Unit 4, Section 6.1, Polynomial Functions, Video 1 of 4. I'm going to start to explore functions that are a little bit bigger than the ones we've worked with. We've currently worked with linear, like 2x plus 1. We've worked with quadratic, x squared plus 3x plus 5. Now we're going to build into functions that are larger than that, so cubic functions and quintic functions, so on and so forth. So this first video deals mainly with vocabulary of items that we're going to be working with. So we've had exposure to some of these words already, talking about expressions based off of the number of terms they have. So in this column right here, these are names of expressions based off of how many different sets of things are being added or subtracted. When you have a monomial, mono meaning one, you have one term, and terms can consist of numbers, variables, and multiplications of those numbers and variables. Once you put an addition or subtraction sign in there, you create another term. Moving to a binomial, so bi meaning two, like bilingual, you can speak two languages. Binomial means two monomials put together, so we have the x to the fifth plus the 7x. That's two terms, therefore a binomial. And then so on, we have a trinomial, which is three terms. And then everything after that, we sum up with the word polynomial. So if you had four terms, you'd say it's a polynomial with four terms. Or if it had 7 different terms in it, a polynomial with 7 terms. So that's one word, or one batch of words we're going to use to classify polynomials. We're also going to classify them based off of their degree. So here's what I mean based off of their degree. The degree of a monomial, or any one term, can be found by looking at the exponent on the variable. So certain degrees that we've seen already, we've seen a degree of 1. That was actually our first unit, which was our linear unit. And when I'm writing out a degree of 1, that's like x being raised to the first power. And we usually don't write the first power in there. It's just like something being multiplied by x. So here's an example of a linear expression, 2x plus 1. And then we just came out of the quadratic unit, where if you think back, all of the inputs, the highest exponent on any input was a 2. And so when the degree is 2, when the exponent on the input, the highest value is 2, that was called a quadratic polynomial. So an example would be x squared plus 3x minus 5, where the input, the largest any exponent on any input, would be 2. Moving up one more degree to a degree of 3, this is called a cubic function. So we'd have x would be raised to the third power at some point in time, and that would be the highest exponent on any input inside of that expression. Moving up to a 4th degree, that'd be a quintic, or excuse me, a quartic. Getting ahead of myself a little bit. Quartic, that'd be a 4th degree, so 4x to the 4th minus 3x squared plus 2. And keeping in mind with degrees, you can have any number of terms. You could have a quartic that is 1 term. You could have a quartic that has 3 terms. Doesn't matter. It's that the input is raised to the 4th power. That's the highest exponent on any input. And then lastly, a 5th degree equation. I said it before, would be a quintic. So 7x to the 5th minus 2x squared plus 1. So every time we classify a polynomial, we're going to use one word from this first column that is based off of the number of terms, and then one word from the second column that's based off of the degree. Other things that we're going to see, this terminology of standard form of a polynomial. That just means when you write a polynomial, you always write highest degree to lowest degree on the terms. For example, over here I had 7x to the 5th. That was to the 5th degree. And then I had 2x squared. The exponent was 2, so that was to the 2nd degree. And then, forgot to write into the 0 degree, so this is like x to the 0 power, which would be the last term, and that's called a constant. So when you're writing something in standard form, you always write highest degree to lowest degree. And if you think back to quadratics, that's kind of how our standard form of quadratic function was set up. We had ax squared plus bx plus c. We had the highest degree, which is to the second, to the lowest degree, which was to the 0 power. And then the degree of a polynomial is always the degree of the highest input. So the highest terms exponent on the input, which is really a fancy way of saying the reason we call this a quintic function is because the highest one given exponent on any input was 5. Therefore, that 5 speaks for the entire polynomial.